Hello, my name is Haley and I'm a food science major from the class of 2019. We will be working through problem number 4 from chapter 4.4 in the general chemistry workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem, then we'll go over it together. So now that you have finished the problem, let's read what the problem stated. It said, a 15 milliliter sample of phosphoric acid is titrated with 0.2 molar NaOH. What is the concentration of the initial phosphoric acid solution if 44.35 milliliters of NaOH is required to completely neutralize the phosphoric acid? This problem is what they call a titration. A titration is the procedure to find the concentration of a solution by reacting it with the standard solution with a known volume and concentration. So in this problem, our known solution is NaOH. And it said we had 0.2 molar and we used 44.35 milliliters. And the concentration that we're trying to find is of phosphoric acid. And it said we had a 15 milliliter sample. So I'm going to draw this as what we would do in a titration. So in the flask we have the acid where we're trying to find the concentration, and we had 15 milliliters. And up here in the burette we had NaOH, which was 0.2 molar. We can find the concentration of the acid by doing a titration. We need to add our standard solution with the known concentration of sodium hydroxide, which was the concentration it gave in the problem. So once we start the titration, we're going to let our NaOH to start dripping into the flask with the acid. So we have an acid that's going to be reacting with a base, and this is called an acid-base neutralization reaction. So let's write out the reaction occurring in the flask. We have our acid plus our base, NaOH, and this is going to create, remember that acids like to donate H ions and bases like to accept those H ions. So your OH is going to form water with the donated hydrogen ion, and then you will form Na3PO4. Let's make sure our reaction is balanced. Let's look at sodium, that might help us. Sodium, we have 1 on the left side and 3 on the right side. So we know we're going to have to put a 3 in front of the NaOH. And then we have 4 plus 3 oxygen, so we have 7. And on the right side we only have 4 plus 1, so we have 5. So we're going to want to put a 3 out in front of here. After that, I think our reaction is balanced. In a titration, to know the amount of NaOH or base that is needed to neutralize all the acid, we normally add what's called an acid-base indicator into the flask. In this case, we normally use phenolphthalein, which is clear in an acidic environment. So obviously if you're in phosphoric acid, the indicator is going to be clear. However, once we add enough NaOH that you're neutralized all the acid, so it's at a neutral point, and then you add 1 more drop so it turns slightly basic. In the presence of a basic environment, this indicator turns pink. So once the solution turns pink, we know that is the amount of NaOH, the volume amount that is needed to neutralize the acid. So that value of volume added was given in the problem, and it said it added 44.35 milliliters. So now that we have gone over some of the basics of titrations and some of the values needed to calculate the initial concentration, we can finish the problem on the next slide. So let's solve the problem now. We kind of went over the background of titration, so let's use the values we found to find the initial concentration of phosphoric acid. So it said it took us 44.35 milliliters of NaOH to completely react with all of the acid present in the flask. So let's start with the concentration of NaOH. It said we had 0.2 molar, which was given in the problem, and we know that molarity is equal to moles per liter. So our goal is to figure out how many moles of base was used to neutralize the acid present. Once we have moles of base, we can convert to moles of phosphoric acid, and that can help us find the concentration. So let's first convert 44.35 milliliters into liters, because we need liters for the equation. So for every 1 milliliter, there is 10 to the negative third liters, so that's 0.04435 liters. So let's plug in. We have 0.2 molarity equals moles over the liters. 0.0. To find moles, just multiply you're just going to want to multiply these numbers together. And then we're going to have 0.0087 moles of NaOH used in our titration. So the next step is we want to convert to moles of phosphoric acid. So to do that, we must look back at our balanced equation. Our balanced equation says that for every 1 mole of phosphoric acid, it reacts with 3 moles of NaOH. We know that this is going to be a 1:3 ratio due to the coefficients we have in front of the compounds. So, because all of our acid has reacted, we can convert moles of NaOH, which reacted with all of the acid, to moles of phosphoric acid. So if we had 0.0087 moles of NaOH, we can use that mole ratio. So for every 3 moles of NaOH, 1 mole phosphoric acid. So we have 0.0029 moles phosphoric acid. So we must have had that amount of moles in the starting solution in the flask. So our goal is to find concentration. And we know concentration is molarity, so that's moles per liter. And now we have both values. We have the moles, which we just solved for, and the milliliters, which was given in the problem. So we just got to plug into that formula. So we can convert milliliters into liters, the same way we did the 44.35. So for every 1 milliliter, there's 10 to the negative third liters, 0.015 liters. And then plug in. So the moles is 0.0029 moles divided by liters, 0.015 liters. So the initial concentration of phosphoric acid was 0.197 molarity. So that's how we use a titration to solve for an unknown concentration of a solution using a base and an acid. Thanks for watching.